Hello everyone, we are Group 3 from Digital Logic Section 3, 2023 and 2024. Today we would like to present about our project, which title is Leaf Electronic Controller System. So my name is Guika Singh, and next I will pass to my friend to introduce himself.
My name is Cheryl Shoktaun.
Hi everyone, I'm Chajalin.
Hi, my name is Lau Ewan. You can call me Ewan or just call me Lau.
Okay, these are the contents of our project. So now we will explain details about the background. So I'll pass it to my friend Cheryl.
So now I want to explain about the background for our mini project. And our mini project is about the implementation of password protected Leaf electronic control system. Our project aims to create a secure and efficient system for controlling a leaf to allow the user to input their laser floor level from 0 to 9 and A to F floor. The full circuit is drawn using a DITS and include combinational circuit and sequential circuit. So the component of the combination circuit is 4-bit comparator, is used to compare the input value for the decision making. The next one is 3-bit decoder to allow the user to input the password. And the next is basic gate, the 7-segment displays, the input switch, and the input push button is to initiate the leaf movement. The next is the component for the sequential circuit is 4-bit up-down counter. It can control whether the leaf is going up or down. The next one is 4 flip-flop is used to memory element for the storing binary value. The next one is clock disable to control the clock signal to synchronize the circuit operation. And the last one for the sequential circuit is the pre-bar and clear bar switch. Is for the input for presetting and clearing the counter so that the flip-flop is in synchronous mode and the clock can operate. And the enhanced feature for the Leaf electronic control system is the 3 binary digit password, and it can add an extra layer for the security to the system, and user must input a specific password that is set by the residents for access. The next one is the LEDs for the leaf going up and down. User can see whether the leaf is moving up or down, and it can enhance the user experience and the system feedback. And I will pass to my friends to explain.
Okay, now I'm going to talk about the problem and solution. To mitigate security concerns such as break-ins, we have introduced a 3-bit binary password system for the leaf. The user initiates the process of the leaf by activating the power and start buttons. Following, the correct password must be entered and the desired floor must be selected. And if the password is incorrect, the leaf will remain stationary. However, if the password is correct, the LEDs will display the chosen floor and the leaf motion direction either up or down based on the user's destination. If the number of floor is the same as the destination of the user, the leaf will not move as an additional security measure. Okay, this is the state diagram of the leaf controlling system, where the 0 representing the count up counter and 1 representing the countdown counter. And the lowest floor of the leaf is start from 0, and the highest level of the leaf is until floor F, which is the 15th floor. And this is the flip-flop transition table for the leaf controller system, and the truth table for the care map for the leaf controller system. Okay, thank you.
This is the block diagram that consists of all components that are used in a circuit. For example, it's LED, input, 7-segment, 4-bit comparator, clock disable, push button, start button, power button, 3-bit decoder, password, and input counter, 4-bit D flip-flop. And this is the very rough diagram for our real circuit, and the full circuit diagram will be shown later.
Okay, now I will talk about the requirements needed to design the leaf. Okay, first we need an input switch. The user can enter their destination using the 4 input switches, and also they can turn on the power and start button of the leaf using the switches. Next is the input push button. The push button is to eliminate unwanted state during transition state. After that, we have input switch X to control the motion of the leaf, either it goes up or goes down. Next, we need a clock disable also. The clock disable is active only when all the inputs are high and the password is correct. It also controls the counter operation when the destination is reached. After that, we have a 4-bit count up or down counter. The counter begins and ends its counting operation depending on the clock enable and input switch X. Next, we have 7-segment display to show the destination of the user and the number of floors of the leaf. Other than that, we have 3-bit decoder. The decoder will decode the password entered by user, and only the password 100 can activate the circuit. Next is 4-bit comparator. The comparator is to compare the destination of the user and the number of floors of the leaf. If both of the floors are on the same floor, the leaf will not move. Okay, the LEDs will light up and indicate the number of floors of the leaf and the motion of the leaf based on the destination of the user. Next is the D flip-flop. The D flip-flop acts as level indicator for the leaf. And lastly is the pre-bar and clear bar button. This button is set to 1 to make the circuit operate in synchronous mode.
So now Ewan and I will explain about the system implementations. First is input switch. There are 7 input switches in our systems, which is preset and clear. And the second one is input push button. The third one is power. And the fourth one is about the password enter. The fifth is desire floor. Just you choose the floor you want to go. And the sixth is start. And the last one is about switch X, which means you choose you want to count up or count down. So just briefly said about what input switch we have. So the description is all inside our report. So next is 3-bit decoder. So our password is set as 3 binary digit passwords, which is 100. So we use this decoders to get our password. So if you key in 100, you will get 4. So you get active high output. And power button is also connected to the enables in the decoder. So the output of the decoder is connected to the clock disable part, which will explain by my friend later. So I'll pass to my friend.
Okay, hi everyone. Now I would like to explain the clock disable part. The clock disable is set up by using a 5-input AND gate. The 5 input AND gates receive the input from the clock source, a 3-bit decoder, a start signal, power button signal, and a comparator signal. The clock disable will only be active if all the 5 inputs are high. The output of the 5 inputs AND gate is connected to the clock, to the counter flip-flop clock, used to start and stop the counter's operation. Next, I would like to explain about the 4-bit count up or down counter. In our system, we use a 4-bit D positive edge count up or down counter. So when the input X is connected to a low input which is 0 and the current flow level is less than the target flow, the counter will initialize a count up counter. Conversely, when the input X is connected to a high input which is 1 and the current flow levels exceeds the target flow, the countdown counter will be activated. Okay, the counter operates upon the correct password entry and facilitated by an AND gate implementing an active high input. So when the password is incorrect, the count will not count. Yeah. Okay, next. Next, I would like to explain about the 4-bit comparator. The comparator circuit is designed with 4 2-input XNOR gates, facilitating the comparison of values from 2 different sources, which is the input switches for the user's desired floor and the current floor occupied by the user. Each XNOR gate focus on the least significant bit. When the number of requested floor and the user's current floor is the same, the output will be the 0. Then the output is then inverted to 1. So the same principle can be applied for the second, the third, and the fourth XNOR gate. Then the signal from all the 4 gates will be sent to a NAND gate to convert it into the opposite signal. Therefore, when the input of the NAND gate receives the high input given from the input switches, it will send an output 0 to the clock disable to stop the leaf. when the user's current floor and the number of requested floor is the same, then the lift will be stopped. So next, I will explain the 7-segment display. The 7-segment display is very important in our system. We got two 7-segment display in our system. One 7-segment display is show the children floor, and the second 7-segment display is display the lift current floor level as it is ascending or descending. The decimal numbers, it will show the decimal numbers from 0 to 9 and letters from A to F to cover the entire range of 0 to 15 floors. Yeah, that's all from me. I will pass to my friends Gui to explain the LED part. Thank you.
So the last one is about LED. We connect the LED switches with the input switch X. So when the input switch X is zeros, the symbol in the left will light out. So it shows the elevator is going up, and when the input X is 1, it shows that it's going down, so the symbols at the right will light up. So this all from the system implementation part. So next, we will show you about the full DIT circuits. I will show the operations in DIT later. Okay, this is the full DIT circuit, just like what we showed in the project. So now I will explain part by part. So firstly, let us go to the user manual. So to operate these circuits, there are 7 steps that we will user may do. So the first one is set pre and clear become 1, and the second one is switch on the power. Third one is enter the 3 binary digit password, and the fourth is input the flow we want to go. The fifth is push either count up or count down, and the sixth is switch on the start button, and the last is activate the clock button. And this is the floor abbreviations in the F. 0 is the ground floor, and 1 is to 9 is as usual, and A is floor 10, and F is floor 15. So it's ascending. So now we just let the circuit. So we follow the step. First one is set pre become 1 and set clear become 1. And take an examples. We want to go to floor 10, which is 1010. So 8. And we need to follow the step. The second step is we need to switch on power. Here is the power. And the third one is we enter the 3 binary digit password. The password is 100, which is the only password we accept. So let me zoom in. So 100 in 1 is the MSB, which is most significant bit. So 1 is here, the A2. So 100. And we go to the step 4. Let's see what is the step 4, which is input the flow we want to go. Okay, we go to 1010, 1010. And which is the next step is push either count up and count down. Now it's count up. So up, just now we explained, which is 0. This is the count up, which is 0. So now it's correct. And the step 6 is switch on the start button. Switch on. And the last one is about the activate clock button. So I need to zoom out to let you see the floor. Okay, this is the initially floor, which is ground floor. Now we want to go to floor A. So now I will click the clock button. So first one. Okay, when we reach the floor A, so even you click the clock, you will never go up because we already reached the floor. And there's a part that I would like to show you guys, which is about the LED part. So since we now is going up, so the symbols light up and going up is being light up. So let me show you about the going down. So now we are at the floor A. Now we are going down. We go to, let us take an example. We go to floor 4, which is 100, and countdown, which is 1. So I change it to become 1, and then I click the clock. Wait for a minute. Okay. So you can see the floor is going down. And when it reaches floor 4, it stops. And the LED also shows the going down symbol. So this is all about our DITs. So next I'll pass to my friend Ewan to conclude our project.
In conclusion, the lift controller project has resulted in a user-friendly design incorporating essential components such as a 3-bit decoder, input switches, 4-bit comparator, 7-segment display, LEDs, and a 4-bit D flip-flop to create an efficient lift electronic controller system. The integration of a password features enhance the security and control over the circuit, while the implemented LEDs provide a clear indication of the lift directional movement. We would also like to thank to our group members who worked hard to complete this project and to present it in our best. Reflecting on this journey, the project has been a valuable learning experience contributing significantly to our knowledge and skill development in electronic control systems. Lastly, I would like to thank to our lecturer, Dr. Nur Fadrina, for teaching us in this semester. That's all from us. Thank you.
Thank you,
Thank you,
Doctor.
Doctor.